movement of an object over time.
Okay, good. Movement of an object over time. Did anybody find anything else?
I said something like similar, but I said an object that changes its position over time.
Changing position over time. So I'm going to put both of those, and whichever one you have is good. So movement. No. I should wear my glasses. I can't see anything I'm doing.
Okay.
All right, so what was the equation for this? Now, this was the trickiest one, I think, for equations, because when something is changing its position or moving, we're talking about actually a lot of different equations here. So what are some of the equations you guys found? Yep. Anthony? Okay, do you know what that stands for? Okay, so anytime you have A for motion, that is acceleration. So we have one that deals with acceleration. What other one did you guys find? So V equals, okay, so the V is velocity. Any other ones?
I don't know if you already said this, but I put A equals F over M.
Okay, A equals F over M, so that's acceleration. What other ones? Online students, you guys can participate also, Ryan.
I just have, there was like a bunch, so I just like copied them. This one is, I put the V one that he just sent, but S equals UT plus half AC squared.
Okay, do you know what any of those letters stand for? Okay. All right, so this one, you guys, I want you to add a few more things. So this is really describing describing displacement, distance, velocity, acceleration, time, and speed. So for motion, we're talking about all of these things because motion can be speed of an object, it can be accelerating, it can be moving a certain distance. So it has to be, so there's lots of things that motion includes. So we're just gonna really focus on the unit of measure here. So what, you guys should all have this now, what's the unit of measure for speed or velocity? How do we measure speed or velocity? Ryan?
Distance over time.
What are the units of measure for that one? So, like miles per hour, but what do we measure in science? What do we measure distance in?
Oh, kilometer.
Okay, the second part of that, not the suffix, the prefix rather. Meters, right? So it's meters divided by our time is what? What do we measure time in? What did I heard it? Second. So meters per second. So that would be our velocity or our speed. And then we also have acceleration. Did you guys see what is the unit of measure for acceleration? Guys, you're supposed to find all this. Go down to acceleration. You have acceleration. What is it? Velocity over time. And we just said that meters per second is our velocity, right? So that would be meters per second over, what's our time? What do we measure time in? Seconds. So it's meters per second. So when we have 2 seconds next to each other, they're being multiplied. What do? How do we write that? Second times second. Squared. All right, so it's meters per second squared. So these are really the 2 unit of measures that we're going to do for motion. All right, where do I go for this superscript? That format? I'll post the video, not the document.
Okay.
All right, so example. What are some examples you guys came up with? So just examples of something in motion that we know something's in motion. Ryan?
Running.
Running. What are some other examples that you guys wrote down? Fabian?
Plane.
What is it?
Plane.
A plane?
Yeah, like flying in the sky.
Okay. Well, the plane. Flying. What else, Ryan?
Driving a car.
What else? Anybody else have anything, Trevor?
Rolling a ball.
All right, so you guys know what the word motion is. So now we're just kind of putting together the scientific thing. So what pictures did you guys find for motion? Give me some picture examples. You guys at home can participate too. We're only going to have stuff from the students here if you guys don't talk up, speak up. What are some things we found for motion? Trevor?
The ball rolling down the hill.
Anybody else? Other pictures?
A person jogging.
A person jogging. Okay, so let's do. This is a good one. All right, so a person jogging would be another one. I'm just going to put this one picture because it's just going so slow right now. What other pictures did you guys have? Someone throwing a baseball. Good. What other things there can be in motion that we might have? That's it, guys? Come on.
Sports.
Any kind of sport? Right. Any kind of sport you're in motion? All right, good. All right, so moving on to reference point. Reference point you guys got a little bit tricked up on, so please pay attention to this one. What is a reference point? What definition did you guys find? Trevor?
I put the movement of one object compared to another movement.
Okay, the movement of one object compared to another's movement. What else did we find? What does that mean in even more simple terms, Ryan?
Well, mine's more of an example. Like, if a car is driving and then there's trees in the background, the trees are the reference.
Why? What are they doing? Are they moving or not moving? They're staying, right, they're staying still. So we know that trees don't get up and like run down the street, right? They are staying still. So if we're sitting out here, actually we can look out the window right now and see cars going by. We know the car is what's in motion and not the trees because the trees aren't going to move. We know that they're staying still. So as the trees go by, we know the cars, as the trees go by, as the cars go by, we know the cars are in motion. Yep.
I have a question before. It's like if there were two cars that were both in motion, but you're measuring the distance between one car from another because one is going faster, would the car that's going slower still count as a reference point?
No, because it's also in motion, right? So it would not be. So our reference point is always something that's not going to move. All right, so we're going to kind of take, did anybody find any other definitions?
I said place or object used for comparison to determine if something is in motion. That's kind of long, but.
Okay, good. So what is that place or object doing, though? Is it moving also? No, it's not moving. Right. So what I want you guys to put then is a stationary place or object or point or object used to compare motion for another object.
Wait, so if I said like a point that marks where an object is in motion?
Use the word stationary. So yes, just add the word stationary to that definition. That would be good. So the word stationary is going to be really key for us here. So I'm going to bold it. So a stationary pointer object used to compare motion of another object. So I like Ryan's example, so I'm going to put that over here as the example, a car driving by a tree. Have any of you ever experienced, if you're like sitting in a car or on a bus and you're at a stoplight and then you see like kind of out of the corner of your eye another car moving and you feel like you're moving but you're not actually moving? So that's where the whole like it feels like you're moving because we see that motion, but then you realize you're not actually moving because you look around and see the other objects are staying still. You're not moving compared to them. Christian?
Doesn't it happen too, like when you're at the beach and you feel like the water is pulling you?
Like if you're standing in the water and you feel like the water is pulling you? I mean, that's more of kind of a force on you, but I see what you're staying still and the water is moving you, so it feels like you're moving even though you're not moving. So I see what you're saying, but I think the force, like, then you have some other senses coming into play with that as well. All right, what examples did we find here? Anybody? What examples did we find? What pictures did we find? What pictures did you guys put? Trevor?
When you're on a train and like you see buildings, it looks like the buildings are moving, but they're not.
I was going to write your whole description. So yes, a train going by buildings. All right, that's a good example. And the same thing, if you found a car driving by a tree, that would be another good example. So something that we know is not moving. Let's do this one. All right, does anybody have any questions with what a reference point is now? So we know that there's no formula for it, there's no equation. Paste it or not. Okay, there we go. All right, the next one down is speed. What definition did we find for speed? Now, this is something you guys probably didn't even need to look up to know the definition of. What is speed, Ryan?
The rate of which an object is moving.
Good. Do we know what rate means? What's an even simpler way? Instead of using the word rate, what do we use? What's even easier? Like how quick or how fast? And you guys know what speed is, so you don't have to change it, Ryan. So how fast something is moving. This one does have a set formula. What is that set formula?
S over dt.
S equals.
S equals distance over time.
Yes. I'm going to spell it all out just for anybody that does not know. So speed equals distance divided by time. And what, we already talked about this, what unit of measure would we use for distance and time? So what would the unit of measure be for speed? Meter, what? Per second, perfect. And of course this changes if we're talking about a car driving, we'd use kilometers per hour, right? Or in America, we use miles per hour. Okay, so what would an example be? Yep.
I just said how fast the car is going.
Okay, so a car, let's be a little more specific. So a car driving from where to where? Okay, so car. So car driving on a highway, we can calculate its speed. What other examples did you guys put? Anybody? Ben, what did you put for your example? Okay, so running. I'm going to say running 100 meter Race. Good. What are some pictures that we put here? Christian, what did you put for a picture?
I put a car going fast.
Okay. So a car going fast. Let's see.
Please pardon the interruption. We're going to call for a shelter in place. If you're expected to be going to a mass or snack break, please delay that. If you're already
Christian,
outside
can you
for a
go
mass
close all
or
the
snack
doors?
break, please just stay out there. We will make the announcement.
Yeah, the far door and then our
Once
classroom door.
again,
Thank
shelter
you.
in place. If you're supposed to go on a mass and snack break, please delay. If you're already outside, just please hang outside in the location that you're at. Thank you.
All right, so you could have put like people running on a track. What other things could we have put for speed?
I put like a cheetah.
A cheetah running. Good. All right, so far these definitions should be very easy, right? We all understand it. Did you guys know the formula for speed already? We already knew it's distance divided by time, because this is something you did in math, and then we did it again when we did the paper airplanes, and then you graphed it. So we've seen it already a couple of times, whether you realize it or not. Yep.
The door is unlocked.
It's okay. They're not gonna shelter in place. Oh wait, is the door supposed to be locked? Give me a second.
Oh, I'm running. I think she locked herself out. No, she didn't.
Our main door is locked, so we're done. All right, so this one, some of you guys too had a lot of questions about average speed. So what is a definition for average speed? What makes it different than regular speed? Who has a definition for average speed? Trevor?
I put the total amount of distance traveled in an amount of time.
Good, the total amount of distance. Now what'd you put? Okay, so the rate of speed over a period of time. Do we know what rate means? Do we get what rate means? Boys?
It's like time or like
Rate usually just means like how fast. Right? So time, what did you say?
the timing of the amount of speed someone or something is going.
Okay, the timing amount of speed. Okay, so I like the total amount of time it takes to, what was your definition exactly, Trevor?
The total amount of distance traveled in an amount of time.
Okay, total amount of distance. All right, so the total amount of distance traveled in an amount of time. You could also just say like how fast it takes to do something. So now this is a little different than speed because it's taking into account like all the stops and starts and going slow for different times. So this is more if we're talking about like a longer distance traveled. So I'm going to skip to an example really quick. Well, what did you guys have for examples? Let me hear what you guys did first.
Track runner being timed on a sprint.
Okay, I would use more speed for that. But yes, you are changing your speeds throughout track running. Yep.
I said like the average speed it takes you like a little far.
Good. Anybody else online? I heard somebody trying to come off.
I said in a car race that they race 5 times.
Okay, so in a car race where you're going around, if you're going in circles, you're changing how fast you're going. So really anything that you're
Good
like.
morning, this is Ms. Source. This message concludes our shelter in place. Resume normal activity.
We need one more announcement. So driving to Florida in 17 hours. So driving in a car, you're changing your speed throughout the time. So really when we're talking about average speed, we're talking about like as.
This is Mr. Amato. This announcement concludes our shelter in place. Resume normal activity.
When the speed kind of changes throughout the time that we're going. So driving to Florida in 17 hours, you guys are leaving from your house, driving through your development. You're driving 25 miles an hour. Then you get onto a highway. In New Jersey, our highways only go up to 65. But then once you get out of New Jersey, it goes up to 70 miles an hour that you're allowed to drive. I know everybody's going faster than that anyway, but less likely of getting a ticket when you're going when the speed limit's 70. Then you might hit some traffic and you're going down to like 20 miles an hour. So you're constantly changing your speed. Your average speed would be that it took me, I had to travel this many miles in this much time over a longer period of time. Brian?
I said like a bus picking up like kids for school.
Oh, that's a good one. Because you're coming to a stop, you have to take buses. Yeah, so that would be another good example. I mean, really, speed and average speed go hand in hand. So if you hear it, but usually you're going to have to calculate average speed when you have like a lot of stops involved. So like a bus would be a really good example. So let me put that one in there too. Okay, so what is our formula? What did you guys find for formula for this?
I put the same thing for speed.
Distance and time. There should be a little bit of a difference. Trevor, what'd you get?
I put average speed equals total speed divided by total elapsed time.
Okay. Wait, total speed divided by total time?
No, average speed equals total speed divided by time.
That would be acceleration. Because you have the speed over the time. Ryan, what'd you get?
I did average speed equals total distance over total time.
Total distance divided by total time. If you guys look this up, you probably saw like a triangle distance and then triangle time. The triangle stands for something called delta. You'll get that you'll see that in math, and you'll probably see it in physics when you get to like high school. So that the triangle or delta just means a change. So a change in distance over a change in time. So this is where our distance and time is changing. But for us to understand it, using the word total makes more sense. So you're calculating all of the distance that the bus is driving or all the distance that the car is driving and dividing it by the total time. So even the time that it stopped, or going super slow, or going super fast, all of that time is included. All right, so I really like the bus example, so I'm going to find that one. What other pictures did you guys find? And you guys don't have to change your pictures. Whatever you have, I'm sure is fine. What other, just while we're waiting for the internet, what other pictures did you guys find? Call it out. Nobody? Come on, you guys are supposed to find pictures. What other pictures did we find?
I did like an airplane, like it slowly gets to the runway and then it accelerates.
Okay. Good.
I got like one that has like two cars and one's going faster and one's going slower.
Okay, so cars, an airplane, the mailman, that's another good one too. That's a lot of stops and starts. You guys are coming up with ones I never even thought of. Okay. Going so slow. All right, the next one is instantaneous speed. All right, What is a good definition for instantaneous speed? So again, we're talking about speed. Oh wait, I didn't do the unit of measure up here. So even though we're changing our distance and time, what would our unit of measure be? For average speed, going back up to average speed, I forgot to do the unit of measure. What's our average speed unit of measure? Meters.
Meters and seconds.
Meters per second. It's still the same. All right, now instantaneous speed. So what is instantaneous speed, Ryan Fernandez?
The speed of an object always changes. It's always changing.
It is always, or could always be changing. It's not always changing. Ryan?
The speed of an object in a particular time.
Yes. So the speed of an object moving. So instead of moving at that moment in time, that instant in time. Anybody have something else? All right, so the speed of an object moving at that instant in time or that particular time. Why would this be important for us to know? Or when would this ever be used? Ryan?
Someone's like pulling someone over, like
Who pulls somebody over? The police, right?
Yeah,
So using a radar gun. What if I'm a super cautious, safe driver, but I'm just having a really bad day, but I know, like, okay, I gotta keep my calm, I'm gonna go nice and slow, and then someone cuts me off and I get really mad, so I'm like way under the speed limit the whole time, someone gets mad at me because I'm going too slow, so they cut me off, I get mad, and I speed past them. At that instant, when I'm speeding, even though I was perfect, like my whole life, I never sped in my whole life, if at that instant a cop is sitting there with a radar gun and they point it toward me and I'm speeding past that car to go past them because I'm upset at that instant, I'm gonna get a ticket, right? So that's what instantaneous speed is. It is that's right then and there. How fast are you going? Speed run. This I think will be our last one for today. All right. So radar gun. Anybody think of any other time? So not just driving. When else do we use a radar gun? Who uses a radar gun? What's something else we want to find the speed of? Some of you guys. Yes, baseball. So how many of you guys have ever gotten your speed of for pitching, for throwing? Oh, hockey too? I didn't know that.
The highest I've seen, the highest ever has been 109 miles per hour.
For hockey or for baseball?
Like shooting a puck, the fastest it's ever been is 109.
Really?
Yeah.
It's interesting because throwing is what's the fastest throwing? Anybody know for throwing a baseball? 105, right? Yeah. So it's. I would think that hitting a puck would be able to go faster than the fastest throwing, but that's pretty amazing how quick then someone's throwing. Imagine being hit with a puck that fast. All right, so our instantaneous speed, we're going to use the same formula as for regular speed, even because it's distance divided by time, even though it is that instant. So it's not really driving a certain distance or time. Did you find a different formula, Ryan? Okay. But what would our unit of measure be for instantaneous speed? Meters per second. All right. Hopefully you guys got this sinking in your head now. All right, let's use, I like the radar gun with baseball. All right, so this is going to be the last one we're doing for today. For homework, if you guys didn't finish, you need to finish up all the rest of the definitions. Does anyone have any questions I feel like so far this is very straightforward, stuff that we are already really familiar with, but we're just kind of getting the equations now behind it. Nobody has any questions? Anybody online have questions? All right. Christian, could you get the light up? Turn the light on, and then everybody else needs to write on your desk.
Close your eyes.